Hello all. So in this video, we'll be starting with the new playlist called Langgraph. So unlike LangChain, Langgraph provides a graphical framework. So in LangChain, what happens is it's a sequential chain. So everything goes in a sequence. So if, for example, there is an input, it goes to this LLM, then it goes to this chain, then it goes to this chain, and then the output. So it flows in one direction. There is no looping. There is no human in the loop involved. There is no conditional chain. If we need, like, for example, I don't want to go to left side, but based on some condition I have to decide whether I should go left or right. So nothing like that is possible in sequential chains, which is LangChain. But in LangGraph, on the right side, you can see that there is a conditional edge or conditional node here. Then based on this condition, we can decide either to terminate the workflow or go back, or based on the condition that we need. There is also a combiner. There is also a router that can route to a particular node. There's also human in the loop. So all those luxuries are being provided by this Langgraph framework. But first things first, let's go to the definition. So Langgraph is a low-level orchestration framework. And why low-level? Because we can specify where we can put the node. So for example, we have to design a flow, right? An LLM agent where I don't want to keep human in the loop here, but I have to put somewhere else. So you can optimize it. You can also change the prompt of an LLM. So for example, you're using this LLM somewhere here in one of the node, then you can also modify the entire prompt. It's not like you have to use the same system design prompt. So all these things happens in N8N and Crew AI. So in Crew AI, what I mean is you have a specified prompt template that you have to use, or the architecture that you have to use. But here you can fully customize as a developer, and that's why it's called low level. So it's an orchestration framework and runtime for building, managing, and deploying long-running stateful agents. So what is state now? That's the most important thing to understand. So we'll see that in this video. We'll also have a Python hands-on. So I will show you step by step the whole code, how to implement a very basic graph. Okay. But first things first, let's understand what the definitions of edges and nodes. So what are edges and nodes? Most of you might know this, but I'm just repeating it. So this is a start node. This is one of the node. This is a chatbot node. This is one of the nodes. Similarly, tools, summarize conversation, end node, all these are the nodes. And what are edges? Edges just connect the nodes. So all these lines here are the edges. That's it. So that's a very simple definition of edges and nodes. But the most important part is state. So as I already said, what is state will be good to understand. So we will simply implement a very simple graph of one node, which is called add node. So there is a start node, one node in between, which is add node, and the end. And what this add node will do, will just add two numbers. So that's very simple workflow. Given two numbers, we need to add, and we are just building a graph for that. I know that we don't need graph for this, but just to get some hands on, it's the best example to start with. Now, what is state? So obviously, for adding two numbers, first we will need two numbers. So let's say it's A and B, and we have to store that result. So this is nothing but a state, and you can see how it's defined. So we need type dictionaries here, because we have to specify what should be the input type. Okay, what should be the data type? Here it can be float as well. While coding, we'll take float rather than int. Okay, but that doesn't matter. So let's try to code this very simple graph. Okay, step by step. So what is state? State is nothing but a shared memory. So this state passes through start node first. Then it goes to add node. What add node will do is it will add two numbers and store that into a result variable. Okay, and then pass on through the end node. Pass this state to the end node, I mean. So it's a shared, right? Because it's shared by all the nodes, and that's why it's called a shared memory. Okay, so I won't make complex things here. Like, for example, there is something called as partial state update, but we'll see that when we'll see the parallel workflows. Okay, when there is a parallel nodes, okay, then we will see that. Right now it will be complex. So let's move towards first simple Langgraph flow. Let's install the libraries that we need, and for that we will firstly create virtual environment. Okay, so here just I created a folder. Inside the folder there is a blank Jupyter notebook, and I'm creating a virtual environment. CMD first. Yeah. Python -m venv.venv and press enter. And you can see that here it should be venv. Here you can name anything. Whatever you will name here, that folder will be created here. You can see this folder popped up. Okay, so it's creating now right now the environment for us, and it's a good practice. Okay, and for all the dependencies, it's a good practice to create a requirements.txt file and put all the dependencies there. Okay, so I'll also meanwhile create requirements.txt, not in this, but I need to create in our parent folder. So that should be requirements.txt. Require, I hope the spelling is correct. Okay, here you can specify all the versions that you have to install. So for example, firstly, we are installing Langgraph. So we'll just install Langgraph here. So you can either write pip install Langgraph directly, but firstly we have to activate this virtual environment, because whatever we are going to install, it should be in this virtual environment so that it doesn't affect any other projects that we will do in future. So for that, what we will do is we will go inside this, inside scripts, and inside this there is an activate script. So if you will go here, there is scripts and there is an activate. So as soon as we hit this, you will get .venv. Okay, now we can install either pip install, that directly we can install here Langgraph, but since we put already Langgraph here, it's good to install via requirements.txt. Pip install -r is for recursive, so it will search for everything in this requirement.txt and hit enter, and it will install for us the Langgraph. Okay, so now let's try to import few things, I mean, until it install. So from Langgraph, it will not show suggestion as of now because it's still installing, but I'm writing .graph. I'm just importing few things that are needed. Import state graph. This will be needed to, now it's showing as well. This we will need to create graph, and that's why I'm doing it. Now this thing is done. This is simple import. Firstly, what we have to do is we have to specify state. So what can be our state? Let's call it my state right now. And what we will pass here is typed dictionary. So we have to also import type dictionary, and that comes from typing module of Python. So this come inbuilt from typing import typed dict. Okay, so that's what we are using here. This is creating a state. So let me just also comment it out that this is our state. Oops, I didn't mean to run the cell. Define state. Now in this, what will go is two variables. Float, b is also float, and our answer or result should be also float. Okay, and let's run this. This is our state. So state is now defined. Now it's time to define the graph. So for that we will be using this import that we imported already. So let's call it graph, and this is state graph, and in this, what passes in our graph? The state, right? So I'll just, so this is now the graph object is being created, but we have to still make the graph, and our graph is so simple. Our graph is simply start, add node, and end. So we have to still make this. Now what we will do is, this is just an invocation of the graph. Now let's add the node. First we will add the node, and then we will connect all the nodes via edges. So it's already suggesting us graph.add node. So what this does is simply we are just adding node to our graph object. So here you can name anything, but let's name it add node because we already named it add node here. So you can name anything here. Okay, this is add node, but this function, now this is the function that we have to define. So here let's define that function, but that name should be add node only. So let's define that function, and this will specify what our node will do. Okay, so this is really important. What goes inside this is a state, and it should be of type this. Okay, my state. So this should be of type my state. Okay, and it's already suggesting correct. That what we are doing is from state, which is of type my state, we are extracting A, extracting B, adding them and storing them into this, and then we can return our state. Okay, we can either return our state or we can return, it's a good practice to return like this, the dictionary, rather than returning the state. Why? Because as I said, while we will implement the parallel workflows, it's problematic because it should be, because here the state is just updating the result variable. So it's better to just update. We will see this in very detail, but right now you can understand that you can either return state or return like this, a dictionary. Okay, so I'll show you both ways once our graph is compiled. So our node is added. Now, after adding node, we have to add edges. So add edges. And for that, what we will need is start node first. So it should goes from start, then add node to the end. So for that, we will need start and end. And that is also here from this module. So start and end. Now we have to connect. So graph.add edge, it's suggesting, see, it starts from start and it connects to add node, which is correct. Then from add node, it goes to the end. Simple. So our graph is complete now. We already added the node and start node connects to that node. This is add node. And the functionality of add node is here, in which the state goes, and this is our state. And this is add node, end node. And then it's time to compile to see if everything is correct or not, like we do compilation. So graph.compile. And if I'll run this now, you will see perfect graph visually, and only in Jupyter Notebook it's possible. Okay, but if I store this in some variable, let's call it workflow, then our graph will not be visible. Okay, but it's okay. Now we can simply invoke this, or let's try to use it. So for example, result will be workflow dot invoke, and let's have a as 1, b as 2, and let's print this, print result. See, we are getting result as 3. So what happens is very simple. I'll just go through it again. Firstly, we created a state. Then we created the node. Firstly, we created the graph object. Then in that graph object, we started building the graph. So firstly, we just add nodes. Okay. So it can be plural as well when we have multiple nodes. And then we connect all those nodes via edges. So from start to this, and then, but the naming should be perfect. Okay. It should not be any typos, or the name should be correct. Okay. Whatever you name here, that should be here. And then we just compile. The one thing I want to show is, even if you write state here and rerun everything, it will work. Not a problem at all. Okay. But it's advisable to not do this, and it's good to do this. And we will see this why. Just a hint is, when we will implement parallel workflows, this will be problematic. So I hope you liked the very first video of Langgraph. I highly encourage you to do this again. It's simply like hardly 10-15 lines, not even 10-15 lines of code. Okay. So going forward, we will implement this now. So we'll now have an actual chatbot. Okay. And we'll try to use a weather tool or a weather API. Okay. And for that, you will need some API key of LLM as well. From my side, I am paying for OpenAI. So I do have OpenAI API key. So be ready for next video with OpenAI API keys. And just to let you know, we'll implement all this. Okay. All these workflows. There are many workflows. If you go to the official documentation here, like there are, you can see there are parallel workflows that aggregates. You can see there is prompt chaining. You see there is some gate where you can have a conditional edge or conditional node, right? So we will, and if you will go through this documentation now, you might be a bit comfortable now. Okay. Here they're using Anthropic API key, but we will be using the OpenAI API key. So stay tuned. Thank you.